and we're going to start our 8.6. All right, so like I said, 8.6 deals with polynomial inequalities. So since I'm talking about inequalities, we're looking at less than, greater than, less than or equals, or greater than or equals, okay? So the thing about polynomial inequalities, y'all, and I'm going to draw a graph here. And I'm just going to go out about 5 on it. That way y'all can sort of see what's going on with these inequalities, okay? So I'm going to give you the graph of f of x equals x squared minus 4. So this graph will have a point at 0, -4, and then it's going to cross over the x-axis at 2 and -2. So my little parabola is going to come up like that. Okay. So an example of a polynomial inequality would be something like this: x squared minus 4 greater than 0. But y'all notice over here, 0 is the x-axis because that's where the y value is 0 at. So there's more than one solution to this because I got this section on the left side and the section on the right side. They're both greater than 0 because all these y values are greater than 0. That's above that x-axis. So what we're going to do is we're going to solve inequalities and we're going to write our solutions as a domain, okay? So like on this one, if I was looking for all the solutions that were greater than 0, that would be all the solutions on this side of the graph, and then all the solutions on that side of the graph. So you would have two sections. So for this example, for my domain, which would basically be my solutions, because that's all the parts that would make it true. So for this, my domain for making this true would be from -infinity till I got to that -2. And then that would union with this section, which starts at +2 and goes towards +infinity. So notice, I don't include the section of the graph that is below the x-axis, because this would make this a false statement if you plugged in for these x's, okay? So your solution is going to be the sections that make the graph true. So I just wanted y'all to sort of see, now if this section down here, if this would have been less than 0, then I would have been looking at this section down here, and it would have went from -2 to 2, okay? So remember, interval notation will show us our solutions that make this true when we're done. So I'm going to show you the steps I follow when I solve these. We're going to be doing them by hand, so I just wanted you to see though what the graphs actually are telling us, okay? So the first thing we want to do is we want to set the polynomial equal to 0. Okay, once I've set my polynomial equal to 0, I'm then going to solve for the variable. Now, in this section, we're dealing with quadratic polynomials with x squareds in them. So you should get two solutions on these, unless you get a one solution that's a repeat. But we should get two solutions. So what I do now to test for the sections, I'm going to set up a number line. Using the solutions that we got from our polynomial. So y'all, what that means, you're going to get two solutions. So when you set up your number line, you're going to have your first solution, which I'll call A, and your second solution, we'll call that B. So you're going to get two numbers and put them in order and create a little number line with them, okay? Now, what we got to do is pick points from each section and plug them into our polynomial to see if they're true or false. If they're true, we shade that section. If it's false, we will not shade the section, okay? So, really, I'll show you my tricks, but I only use one test point, and I usually only test 0. So, we're going to set up a number line, and then I'm going to test the section where 0 is located. So whatever section 0 is in, I'm going to check that section out and see if I plug a 0 into my polynomial, whether it's true or false. If it's true, when I plug 0 in, then I'll shade that section. So shade the section 0 was located. If I plug 0 into my polynomial and it's false, if it's false, then I do not shade the section. So do not shade the section 0 was located. Now, there's two cases that'll happen when we do this. So here's my A and B. So y'all say this. Say 0 was located in between A and B, and it was true, then I would only shade that section where the 0 was located. Now, if 0 was located in between A and B, so if 0 is located between A and B and it's false, and I do not shade the section where 0 was located, that means you're going to be shading the two outer sections. Okay, so these graphs are going to shade in between the two solutions, or they're going to shade outside the two solutions. One case or the other, okay? Now, once I've shaded and figured out what sections I need to shade, I then write my answer in interval notation. So y'all, if it's like this, interval notation will go from your first number to your second number only. If it's this style, your interval notation will go from negative infinity to the first answer, union to second answer to positive infinity. Now, here's the thing about inequalities. if you got equals, in your polynomial, then we got to use brackets around the numbers. If it's greater than or less than, and you do not have any equals on it, then we're going to use parentheses around the numbers. Okay, so brackets mean the numbers make it true. Parentheses mean the numbers make it false at that point, okay? Now, like I said, the only time we won't get one of these two situations is if we get a single number that's a repeating answer. So if we only get one solution, then that is the only number excluded from the domain. Okay, so what that means is if you only got one number, that's when the graph was tangent, remember? So those kind of graphs would come down, touch the x-axis, and go back up. So if you had one of these, then there would only be the one number that would make it true in that case, okay? Now, the only other thing we got to worry about, if the polynomial does not factor, then we have a no solution. Now, y'all in Math Lab, no solution looks like a 0 with a line through it. Okay, so that's their symbol for no solution inside of Math Lab, okay? So these problems are all factorable if you're going to be able to solve them. Now, like I said, you can graph and get solutions by finding x-intercepts and all that fun stuff. But y'all, I'm just going to sort of solve these by factoring, okay? So that's why we was hitting all that greatest common factor stuff and factoring last week. So y'all, here's our steps. They're not bad once you see it being done. So let's get started and do our first example. And y'all, all these are going to say is solve the following inequality. All right, so number one, I got this. X minus 2 times x plus 3 has to be less than 0. So this one was already factored. They're just wanting us to start out with baby steps on this. Now, I'm going to ignore the less than until I start testing my points. So at this point, I'm just going to take both my factors and I'm going to set this whole thing equal to 0. That way I can solve this now by setting x minus 2 equal to 0 and then my x plus 3 equal to 0. So we're going to solve this and get our two solutions. So y'all, the first one, we're just what? Going to add 2 to both sides. And again, x equals a positive 2. For the second one, we're going to subtract 3 from both sides. And again, x is a negative 3. So I'm going to set my number line up. Now remember, I'm going left to right on the number line, so the left side will be the -3. Right here will be -3. And then the +2 will be my second solution. So I've got my number line set up. So now I'm going to test 0. Now check this out. 0 would be in this section right here between -3 and 2 on the number line. 0 is right in there between both of those. So we're going to test 0 in this polynomial. If it's true, we're going to shade that in the middle. If it's false, we're not going to shade the middle. We're going to shade the outsides. Okay? They're either going to shade in the middle or on both of the outsides. Okay? So y'all, let's put a 0 in for this inequality. I got 0 minus 2 times 0 plus 3 has to be less than 0. So is this true or false? Well, 0 minus 2 gives me a -2. 0 plus 3 is 3. So now I'm looking to see what -2 times 3 is. That's going to give me a -6, less than 0. That is true. So since that's true, let me write my number line again. There's -3, and there's 2. So since -6 is less than 0 is true, and 0 is in the section between -3 and 2, that means we're going to shade the section 0 was located. So shade the section 0 was located. All right, so now I know my interval notation is going to start at -3 and it's going to end at 2. So the question I would ask, would I use brackets around these numbers or would I use parentheses around these numbers? So now I'm going back and looking at my actual polynomial, which is a less than. So chat's starting to light up. So let's see. So parentheses, good job. So my final answer would be parentheses -3, comma 2, and close my parentheses. So if we were to graph this, since it's less than 0, this little section right here would be the only part that would be below your x-axis, okay? So, y'all, that's the trick of it. Solve it, set up a number line, test your number line, okay? Now, like I said, they started out factoring for us. So let's see what they got here. X squared minus 14x plus 33 has to be greater than 0. All right, so we're going to factor this to solve it. And remember, we're going to set it equal to 0. And once we get our two solutions, we'll make our number line, okay? All right, y'all, we got an x squared, that's an x and an x. So y'all, all I need to know is what's going in these parentheses. You got a -14x in the middle, you got a +33 at the end. So if we're going to get the right number line, we need the right two numbers going inside these parentheses. Now we do know this. The last number is positive, so both of these factors will be negative like the middle number. So remember, last number positive, you got to have like signs here. All right, y'all, now I need factors of 33. Factors of 33, that'll equal 14. Um, what you got there? 11 and 3, perfect. All right, so -3, -11, add to get -14, but -11 times -3 multiply to get 33. All right, y'all, so now we just set everything equal to 0 to get our numbers. And remember, at this point, all we're doing is changing the numbers from a -11 to a +11. And same thing, this -3, when we solve it, will give me a +3. So look here, here's your number line. First answer would be 3, it would be on the left. And then 11 would be off to the right side. Now, I'm still going to test 0, but y'all, here's the thing. 0's in the left section this time, because this side goes from -infinity up to +3. So 0's located in the first section this time, but I can still test it, because if it's true for this section, I'll shade this first section and the last section, right? Because these two sections always get shaded together. Now, if it's false in this first section, the only section I'll shade would be the middle, okay? So true, I'll shade the edges. False, I'm only going to shade the middle. So y'all, here we go. We're going to test our 0. Now, the reason I picked 0 because it's easy to plug back into here. 0 squared, which is a big 0, minus 14 times 0, which is a big 0, plus 33 has to be greater than 0. So here's my question. Is this a true or false statement? When y'all evaluate that thing, would it be true or would it be false? So what are we saying? We're saying true, good job. Y'all, because 0 minus 0 is 0 plus 33, you're going to get 33 greater than 0, which is definitely true. So I'm going to come down here and now, y'all, you don't have to keep rewriting your number line. You could go back up here and start shading. I'm just doing it so y'all can see all my steps. So since that's true, I'm going to shade where 0 was located. But y'all, since 0's in the first section and true, you automatically have to shade the other outside region, okay? Now, all we got to do is write this in interval notation. So since you're shading the outsides, your interval notation will have two sections. This left side is starting at -infinity till it gets to the 3. Oh yeah, y'all, parentheses or brackets on this one. Hey, also my number, parentheses or brackets. And we're looking at that inequality. Okay, so you got parentheses, good job. So that'll be 3 parentheses. And then you're going to union it from, now y'all, we can't start with 3 on that because this interval is not included. We got to start where the second interval starts, and that would be at 11. And then from 11, this one heads out towards positive infinity. Good job. Okay, so that's the trick on these. Figuring out. Now, you don't have to test 0. Y'all could have tested a number in between here. You could have did a 5, 6, 7. It don't matter. But if you would have put them numbers in here, you would have seen that anything in the middle would have made that false, okay? Y'all, the only reason I use zero, because look, zero is easy to multiply, okay? And that's the only reason I'm using that zero. All right, y'all, so let's move this down into number 3 here. All right, x squared minus 4x minus 18 is greater than or equal to x minus 4. So here's the thing on this one. I got stuff on both sides. But y'all, guess what? I need on the right side is a big 0. So we need to get a 0 on the right side. So get a 0 on the right side. And to get a 0 over here, I'm going to subtract the x from both sides. And I'm going to add 4 to both sides. Now this side, I'm just trying to line them up where I'll have my like terms together, okay? But notice, positive x, you subtract x from both sides. Negative 4, you add 4 to both sides. So that'll bring down this x squared. Negative 4, negative 1, give me negative 5x. Negative 18 plus 4 gives us a negative 14. All that will now be greater than or equal to 0. So we now have a 0 at the end. So I'm going to factor in and actually set it equal to 0, okay? So I've got an x and an x. Now y'all watch when I factor this one. This last number is negative. Anytime the last number is negative, you're going to have unlike signs. One will be positive, one will be negative. Now, whatever my larger number is, it's going to be negative like the middle. And when you got a minus in front of the 14, you want factors of 14 that'll subtract and give you 5. So Jackson, what y'all got? A 7 and 2, perfect. So my 7's the larger number, is positive, is negative like the middle. And then y'all, the 2 would be positive. Good job. All right, set these equal to 0. And basically, we're just going to change signs again. So the 2 becomes a negative 2. And then this negative 7 will end up being positive 7. So we've got our 2 solutions. We're going to make our number line. So let's see. So negative 2 would be first. And then my 7 would be second. All right, y'all, hang on 1 second. Okay. All righty, so now, once again, I'm going to test 0. And I know now 0 is actually in between negative 2 and 7 on this number line. So when we test 0, we're either going to get true or false in that section there, okay? All right, so to test 0, y'all, you can use this first equation or you can use this second equation. I think it'll be easier to use this second equation where I got everything on one side greater than or equal to 0, but you could use the first one. It does not matter, okay? So, well, I've been doing the easier ones, so let me do the top one. I'll actually do the top one. That'll give me 0 squared minus 4 times 0 minus 18 has to be greater than or equal to 0 minus 4. Well, y'all, this is 0. That's going to be 0. So all that's left on the left side is a negative 18. Greater than or equal, and y'all 0 minus 4, that's just going to give me negative 4. So since I'm using zeros, it don't matter which one of these I use. It's still pretty much, is this number greater than or equal to that number? So my question, is that true? Is a negative 18 greater than or equal to negative 4? Y'all are saying false. Good job. So since this is false, I've got my number line. 0 was in the middle and it was false. So that means we got to shade the outside edges. Okay. So that means if I would have picked numbers over here like 1 or over here like 8, 9, 10, those numbers would have made that true when I plug them in, okay? All right, y'all, so let's see. We know we're starting over here at negative infinity on this one. So around that 2, are y'all putting brackets or parentheses? All right, so we're going to use brackets, y'all, and that's because of the equals on it. Anytime you got an equal, you got to have brackets around that number, and y'all will union it. And then my right side will have a bracket from 7 to infinity. Okay? All right, y'all, so that's the trick on it. Setting up that number line and just sort of testing those points, okay? And really, that's all you're doing on this, all we're doing on this section is looking for solutions and then writing their number lines. So let's see. Oh, number 4, what'd they do? They did an x squared greater than 25. So I'm going to set x squared. Now, here's the thing. When I had trinomials, I wanted everything on one side equal to 0. Now, we'll say I'm going to solve it by factoring doing that. But if you wanted to on this one, you could set x squared equal to 25 and do the square root stuff. And then your two answers would be whatever the square root of that 25 is, okay? But I'm actually going to show you, since they're focusing on factoring in this section, that's what I'm going to play with, okay? So I'm going to get a 0 on the right side. All right, so to get a 0 on the right side, I'm going to subtract 25 from both sides. So x squared minus 25 has to be greater than 0. All righty, so I'm going to set it equal to 0 and solve it now. So x squared is an x and an x. The last number's negative, so you're going to have a plus and a minus. So since there's not an x in the middle, we treat it like a 0. So I need factors of 25 that'll subtract and give me a 0 since there's no x in the middle. Well, y'all, let me tell you what. We call this kind of stuff the difference of perfect squares. So the square root of x squared is an x and an x. Square root of 25, good job, will be a 5 and a 5. Okay, so perfect squares always factor into conjugate pairs like this. So on number 4, you're going to just basically take the square root of that number. Because remember, square root of 25 is a plus or minus 5, right? And you'll see we get the same answers no matter which way we went on that one. So this one I would subtract 5. And then over here I would add 5. I really think they want y'all to get used to these perfect squares because they factor pretty quick, okay? All right, so I got my 2 solutions. So we're going to make our number line up. Let's see, we got what? -5 over here and +5. Well, guess what? 0 is sitting right here in the middle again. So I'm going to test my 0. And I'm probably going to do that very first one. Because that is pretty quick. It says 0 squared greater than 25. True or false? So is 0 squared greater than 25? Definitely false. Good job. All right, y'all. So we know technically, since that's false, we will not shade where the 0 was located. Since that was false, that means we're going to shade the 2 outside edges. Okay. So that means every one of these x values that I shaded, if you square it, it's going to be greater than 25. All right, here's a 6. 6 squared is 36, bigger than 25. 7 squared is 49. 49 is greater than 25. -6 times -6 is 36. 36 is greater than 25. Any x value that you shaded makes that true. But if you pick one in the middle, like say a 1, 1 squared is 1, and y'all 1 is not greater than 25. That's why that ain't shaded, okay? All right, let's see. We only had a greater than, so it looks like we're using parentheses. So this one would go from -infinity to -5, union +5 to +infinity. Now, the trick you got to watch out for on that, what gets a lot of people, is they'll go like -infinity, -5, -5 to 5, and then they'll do 5 to infinity. Well, if you include that section there, that's going to make it wrong because that section makes this all false, right? Oh, y'all, let's see what they're doing here. 225 minus x squared is less than or equal to 0. Now, I'm going to show you a few things I would do to this one. First off, I'm probably going to put it in order. I'm going to do -x squared plus 225 is less than or equal to 0. So I rearranged it. Now, another thing we want to do, we don't want the x squared term to be negative. So at this point, we're going to divide everybody by -1. Okay, we're going to divide all 3 of these by -1 so that our x squared becomes positive. So what are you doing to this thing right here since you're dividing by negative? Guess what? When we divide by negative, we reverse that inequality. So that less than or equal is now going to become a greater than or equal. So remember, reverse the inequality. Since dividing by negative. So negative divided by negative makes that a positive x squared. Positive 225 divided by -1 makes that a -225. that is now greater than or equal to 0. Okay, so although we're basically trying to get these to where we can factor them, they're still hitting you with other things they want you to remember, such as flipping that inequality, okay? All right, I got perfect squares, and I'm now going to set everything equal to 0. So the last number is negative, so one's positive and one's negative. So y'all, we need the square root of 225 if we're going to go further. Because remember, these are perfect squares. So find me the square root of 225, and we'll be able to plug them numbers in right there. So good job. Y'all should be getting a 15 and a 15. All righty. So I know what my number line is going to be because all I'm doing is changing the signs on both of these so that I can solve them. So right here, moving that over, we'll get a negative 15. And in here, we add 15 and get a positive 15. So we got our solutions. We're going to make our number line. So y'all, what do we get? Negative 15 and 15. So guess what? I know 0 is right in the middle of those. So y'all, what's nice is when I test my 0, I can use this equation. I can use that equation. It don't matter. I can even use this equation. I get the same result on any of those. So I'm just going to use the original. I got 225 minus 0 squared has to be less than or greater than 0. True or false? So is this one true or false, y'all? 225 minus 0, is that less than or equal to 0? Oh, y'all got one up there. False. Good job. Because y'all, this would be what? 225 less than or equal to 0? So that's false. So let me make my number line again. So since 0 was in the middle, we will not shade that middle. We're going to shade our outsides. Okay. All right, so here we go. Negative infinity. It's got equals on it. So at negative 15, we're going to use a bracket. And then that'll union from the positive 15 to the positive infinity. Okay, so y'all, the trick is, now, like I said, at this point, since it's the x squared in a 225, you could have moved the 225 over and done square roots, and you would have still got the same two answers, okay? I'm just trying to sort of play like the factoring like they're doing. All right, y'all, look at this one. 14x minus 49 minus x squared is less than 0. So y'all, looks like we're doing a few things to this. First thing, this thing's out of order. So we want this negative x squared to be in the front. So I'm going to rearrange it. So negative x squared plus 14x minus 49 has to be less than 0. Oh, now look what happens, y'all. So the first step I did, rearrange. But we don't like that negative there. So we're going to divide everybody by -1. So negative x squared divided by -1 plus our 14x divided by -1 minus that 49 divided by -1. And then over here is a 0 divided by -1. We're dividing by negative, so we're going to reverse the inequality. So reverse the inequality since dividing by negative. All right, so we did that. Now the x squared will be positive. The 14x will now be negative. The -49, negative and negative will now be positive. We're greater than, and then 0 divided by -1 is a 0. All righty, so now we're looking at this. We got to factor it. And at that point, I'm just going to set everything equal to 0. So y'all, here's the x squared. This last number is now positive. So both of these factors are going to be negative. All right, y'all, so I need my factors of 49. That'll equal 14. So 7 and 7. Good job. Well, y'all, these are repeating factors. So to solve it, all I got to do is set one of these equal to 0 and solve it. And that's going to give me x equals 7. 7 is the only solution for this polynomial. So y'all remember what I said? If I only got one solution. So here we go. Only one solution. So 7 is the only number. So 7 is the only number we exclude from the domain. And y'all, if you were to graph this, you would see that at 7 on the x-axis, this graph is just going to come down, touch that x-axis, and it goes back up. Remember, we said if it had an even multiplicity, which would happen on this because there's two 7s, then even multiplicities were tangent to the x-axis, okay? So that's why it's only got one number for its solution. So if I'm only going to exclude 7 from my domain will start at -infinity, and it goes until we hit 7. And then we're going to union around 7 until we hit positive infinity, okay? So on your number 6, you're only going to get a single solution that's a repeat, okay? So that means that will be the only number you're going to exclude from your domain. But it's got to include all the other numbers, okay? Y'all, oh, y'all know what? It's almost break time, but we've only got one more number to do. So I think we'll just knock out this number 7, and then I'll see if y'all got any questions. So y'all, here we go with this one. X squared plus 22 is less than 8x. All right, well, guess what? We need a 0 on the right side. So that needs to be 0 right here. So y'all, to make that a 0, we're going to subtract 8x from both sides. Now I'm just sort of sticking it in the middle because there are no like terms over here. So that'll give me my x squared minus the 8x plus the 22 less than 0. So y'all just watch when you move something from one side to the other, all we're doing is changing the signs in the long run, okay? All right, y'all, so let's see if we can factor this one. And at that point, I'm going to set them equal to 0. So I need an x and an x. The last number is positive, so both of these will be negative like the middle. All right, y'all, so find me factors of 22 that'll add to get an 8. Jackson, good job. There are no factors of 22 that'll add to get an 8. Let's see, 22 only has 1 and 22. Those add to get 23. 2 and 11. Those add to get 13. So this one does not factor. So since it does not factor, that means it's a no solution. And y'all remember, no solution on MATLAB is going to be a circle with a line through it. Okay? All right, y'all, let me see. So y'all, that is 8.6. So let me ask y'all, any questions over this 8.6? All right, y'all, I'm trying to see where my chat goes. So I'm not seeing anything. Any questions over anything else? Um, so here's the game plan. Tomorrow we'll come in, we're going to knock out our test 3 review. So that's got 20 questions. And I've got the review open now so that if you want to look at that, sort of play with it before we review or whatever, just to see where you might be needing extra help at. So 8.6 was just, like I said, 7 problems. So if you want to play with the review before we actually review, that'll work. Other than that, tomorrow we're pretty much going to knock out test 3 review. I'll probably explain a little bit about what the 4th test material is. And then I'll decide whether we actually get into that material or not, okay? Because really want y'all to focus on this test 3, okay? All righty, so y'all, any questions at all? Because what I'm going to do, I'm going to let y'all go for today. And that way y'all can sort of keep it light today. So if you're behind on any homework and stuff, that'll give you more of a chance to sort of catch that up. Y'all remember, we're in 4th week starting today. So we got this week and then next week, and we're done for the summer, okay? All righty, y'all. So here's the thing. I'm seeing no questions at all, so I'm gonna let y'all go. And I'll see y'all tomorrow morning at 10 a.m.